Good morning, dear student. In today's lecture, we are very much interested in the hydroformylation reaction. This reaction it is also known as oxo process, which is catalyzed by the catalyst dicobalt octacarbon. This is an organometallic catalyst which converts these alkenes, that is terminal alkenes, into aldehydes. So this hydroformylation reaction it is also known as oxo process. The conversion of this alkene with the help of CO and the catalyst, that is dicobalt octacarbonyl, to convert this alkene into aldehydes. So this is the oxo process. It is used to convert. So this is the first point. Let us see some important points regarding to this reaction. So the alkene conversion of terminal alkene into aldehyde. This reaction it is useful for conversion of terminal alkene to aldehydes. Second, each step in hydroformylation cycle may be categorized according to the characteristic type of organometallic reaction. So each step in hydroformylations may be categorized according to its characteristic type of organometallic reaction. Organometallic reaction. Organometallic reactions such as oxidative addition, reductive elimination, insertion, beta hydride elimination, like that. So each step in a hydroformylation cycle may be categorized according to its characteristic type of organometallic reaction. The cobalt containing intermediate in the cycle alternate between 18 and 16 electron species. So whatever the intermediate, cobalt containing intermediate having 18 and 16 electron species. 18 and 16 electron species. So whatever the intermediate, it is of 18 and 16 electron species. This 18 electron species react to form. This 18 electron species, if you consider, whenever the species is 18 electron, the 18 electron species react to form this 18 electron species reduce their electron count by 2. 18 electron species reduce their electron count by 2 by different methods such as ligand dissociation of carbonyl from this cobalt complex, dissociation, then 1,2 insertion, then alkyl migration, or reductive elimination. That is, the 18 electron species reduce their electron count. So conversion of 18 electron intermediate into 16 with the help of these processes, that is ligand dissociation, 1,2 insertion, alkyl migration, or reductive elimination. Similarly, the 16 electron species can increase their electron count. 16 electron species increase their electron count. 16 electron species increase their electron count by coordination of aldehyde. 16 electron species increase their electron count by coordination of aldehyde or carbonyl or by oxidative addition. It is not aldehyde, it is alkene, coordination of alkene. So whatever the 16 electron species, it can increases their electron count by coordination of alkenes, by interacting with alkenes or CO, or by oxidative addition. Generally, this reaction, oxo reaction, is carried out at a high pressure, that is 200 atmospheric pressure, and temperature, that is 90 degree to 140 degree, in presence of catalyst. That is, so it is carried out at high pressure, that is up to 200 atmosphere, and the temperature for this reaction is 90 degree to 140 degree, in presence of solvent, so this is the reaction, that is conversion of terminal alkenes into aldehyde with the help of catalyst, that is dicobalt octacarbonyl. So let us discuss the reaction and the cycles, or the different steps in this oxo process. That is, this is the general reaction, that is R C R double bond C H H, a reaction with what, that is CO, in presence of dicobalt octacarbonyl and H2, to gives R2CH CH2 C double bond OH. So we get conversion of alkenes. There is a conversion of alkenes to aldehyde by oxo process, that is dicobalt octacarbonyl. So the active catalyst for this oxo process is your HCO by 4. HCO by 4. This is your active catalyst for this process. So initially, the conversion of this dicobalt octacarbonyl to HCO by 4 with the help of this H2 is occur. So how this conversion is occur? That is, this dicobalt octacarbonyl, it will react with H2 and the formation of HCO by 4. HCO by 4. So if you consider this dicobalt octacarbonyl, there is a one metal metal bond, that is this cobalt metal metal bond, and this is CO by 4 and this is CO by 4. By the addition of S2, so this S2 addition cleave this metal metal bond and convert this dicobalt octacarbonyl into HCO by 4, and this is the active catalyst for this oxo process. So there is a cleavage of metal metal bond. So let us discuss the steps involved in this reaction. So if you consider this is your HCO by 4, and if you consider this is your 18 electron species, because this cobalt having 9 electrons, this hydrogen contribute 1 electrons, and the 4 carbonyl contribute 8 electrons, so it is total 18 electron species. So this is 18 electron species. So we know that the 18 electron species, so we already discussed, whatever the 18 electron species, it will reduces their electron count by different methods. The first step is the dissociation of the carbonyl. So this is your 18 electron species. 18 electron species, it undergo a dissociation of CO, means the CO ligand is lost. A dissociation of carbonyl, and we get this species, that is HCO by 3. So we get a 16 electron species, you get a 16 electron species. This is the first step in this oxo process. That is, whatever the catalyst, active catalyst, it undergo dissociation of one carbonyl from this HCO by 4, and to convert into this HCO by 3, it is your 16 electron species. And after that, this 16 electron species, it will uh, binds with your alkene, that is coordination of olefins. The second step is the coordination of olefins, and again this 16 electron species is converted into 18 electron species by coordination of olefins, that is this cobalt, that is HCO CO by 3. This cobalt, it will binds with these alkenes, and the bond is formed by donation of pi electrons. Okay, and we get here, this is your carbon having R group, and this is your hydrogen. So the second step, the first step is what? The dissociation of this carbonyl from this active catalyst, formation of 16 electron species. Next, the 16 electron species again convert into 18 electron species by the coordination with olefins, that is coordination of olefins convert this 16 electron species into 18 electron species. After that, if you consider, whenever there is a if you consider this is an 18 electron species, and if you consider whenever there is a carbon carbon double bond is there, and we know that 18 electron species is there, so there is a chances of whenever the metal, it is directly attached to the sigma donor ligand such as hydrogen or methyl, then there is a chances of insertion reaction. So in this case, this 18 electron species undergo 1,2 insertion reaction. So this species undergo 1,2 insertion reaction. So we already discussed this insertion reaction, that is 1,1 insertion and 1,2 insertion reaction. That is, when there is a 1,2 insertion reaction, the heptacity 2 is converted into heptacity 1, and again there is a conversion of this 18 electron species into 16 electron species. That is, if you consider this is your carbon number 1, this is carbon number 2, so this hydrogen, it is transferred from this cobalt to this carbon number 2, and the heptacity 2 is converted into heptacity 1. So means the only one carbon is attached to the metal atom. So what you get here, so we can write here, so this is your cobalt having 3 carbonyl, and then only 1 carbon. So let us consider, I will make a mistake here, so this is, let us consider this is carbon 1 and this is carbon 2, and the hydrogen is shift from this cobalt to carbon number 2. The hydrogen, it is shift from this cobalt to this carbon number 2, and the heptacity 2 is converted into 1. So what you get, CO3CO, then we get only the carbon number 1 is attached to the metal, that is we get CH2, and then we get CHRR, because the hydrogen is transferred from this metal atom to carbon number 2, and therefore it is 1,2 insertion reaction. That is, let us consider this carbon number 1, this is carbon number 2, so hydrogen is transferred from metal atom to carbon number 2 of alkenes, and the heptacity 2 is converted into 1. Again the 18 electron species is converted into 16 electron species. 18 electron species is converted into 16 electron species. So let us discuss the next step of this cycle or oxo process. So the first step is the dissociation of carbonyl, then second the coordination of olefins, then the third, that is 1,2 insertion reaction. After that 1,2 insertion reaction, again the 18 electron species is converted into 16 electron species, that is your CO by 3, CO, CH2, CHRR. So this is the species, that is your 16 electron species. After that, 1,2 insertion, this species undergo addition reaction, that is addition of one carbonyl, addition of carbonyl, again it is converted into CO by 4 CO CH2 CHRR. So again it is converted into 18 electron species. Again it is converted into 18 electron species. And we know that whenever there is a sigma donor ligand is present in the intermediate or in the complex, then there is a chances of 1,1 insertion reaction, or it is called as alkyl migration. So there is a chances of alkyl migration. So we can write here alkyl migration, that is, so this is your cobalt, so we can write here alkyl migration. So we are already discussed this alkyl migration in previous lecture, that is, so what you get here, CO by 3 CO, here we get C double bond O CS2 CHR, and again this species, this is your alkyl migration. Alkyl migration, and 18 electron species is converted into 16 electron species. Alkyl migration, the step is that alkyl migration. So whenever there is sigma donor ligands and carbonyl ligand, strong pi acceptor ligand is present, then there is a chances of alkyl migration, that is, this R group is migrated to one of the carbonyl, and the conversion of this CO3 CO, that is 3 carbonyl is there, cobalt, and then C double bond O CH2 CHRR, that is alkyl migration, we get 16 electron species. So dissociation, coordination, 1,2 insertion, addition, alkyl migration, and then the next step is the addition of H2, means the oxidative addition. The next reaction is oxidative addition, that is CO by 3 CO, here hydrogen, and this is your R group, CH2 CHR, R group, that is your oxidative addition reaction. The next step is your oxidative addition reaction. So we are very much familiar with this oxidative addition reaction, that is this CH2, it is your non-polar species, so it undergoes cis addition. So in this lecture we are not very much interested in the stereochemistry, so just it undergo oxidative addition and convert into 18 electron species, and the final stage of this cycle or this oxo process is that this 18 electron species undergo a reductive elimination reaction. So finally they undergo, so if you consider this reaction, finally they undergo a reductive elimination reaction, So 2 cis ligands are removed. So what you get, reductive elimination, that is this hydrogen and this R group is removed. This hydrogen, okay, is removed, and what you get here, so I will make a mistake here, that is it undergo oxidative addition, means CO3 cobalt, then hydrogen, then C double bond O CH2 CHRR, and finally this R group containing carbonyl and this hydrogen is removed, that is undergo a reductive elimination reaction to get aldehyde, that is we get this H C double bond CH2 CHRR, and we get again our active catalyst, that is plus, we get H CO by 3, HCO by 3, so we get this HCO by 3. So the conversion of alkenes into aldehyde with the help of this oxo process. So you should remember all these steps. That is the first step, that is the dissociation of the carbonyl, from the active catalyst, that is HCOCO4. Then the conversion of 18 electron into 16 electron species. 16 electron species undergo coordination with olefins, carbon carbon double bond, again convert into 18 electron species. And whenever if you consider whenever these alkenes is interact with this metal atom, then there is a chances of 1-2 insertion reaction, that is it is a reverse of beta elimination reaction. So it is just a reverse of beta elimination reaction. And then there is a conversion of 18 electron into 16 electron species, then addition of carbonyl is there, again it convert into 16 to 18. And then there is a conversion of then there is a alkyl migration. Whenever a sigma donor and pi acceptor ligand is present, then there is chances of 1-1 insertion reaction, that is it is known as alkyl migration. So 18 electron species is converted into 16 electron species. And the next is oxidative addition of H2. So oxidative addition, again the 16 electron species is converted into 18 electron. And finally the 18 electron species undergo reductive elimination to give your product, and with active catalyst as remain as it is. So this is all about oxo process. In next lecture we will discuss the remaining process of our chapter. Thank you.